Okay, we're going to take a look at the second part of our matrices, and we're going to look at adding, subtracting, and multiplying the matrices. To add or subtract matrices, essentially what you do is you add or subtract the corresponding entries. Okay, so if we look at this first one, we have that the number 1 here corresponds to the 5, so we'd add 1 and 5 to get 6. And then we would add the 2 and the 10 to give us 12. Now, in order to add or subtract two matrices, we can only do that if they have, if they have the same dimensions. Very important. Very, very important. Okay? So if we look at our first one here, we see that here we have a 2 by 2 matrix, and we're adding that to another 2 by 2 matrix. So in that case, we can add them. And if we look at the second example, we have a matrix that is a 3 by 1, and we're going to add that to a 3 by 1. So these are cases where we can add and subtract them. If we look at the ones right next to it that have the different dimensions, we have here, our first one is 1 row by 2 columns, and this one is 2 rows by 1 column. Well, and that means we cannot add them together. So let's just take a look at a few examples. So we have matrices W, X, Y, and Z, and we'll just kind of take a look at what we can do with them. Let's say we want to add matrix W to matrix Y. Can we? We can only add them if they have the same dimensions. So if we look at W, we see we have 2 rows by 2 columns, and Y, we have 2 rows by 2 columns. So we'll be able to add those. So let's look and see what happens when we add them. We add each corresponding entry. So we bring down both of the matrices, and now we add the corresponding entries, and this is what we will end up with. So we have the 3 plus the 1 for 4. We have the negative 2 plus the 4. We have the 1 plus the negative 2. And we have the 0 plus the 3. And all you have to do is add them up. And here's what you get. And there it is. Go back. So you end up with another 2 by 2 matrices with entries of 4, 2, negative 1, and 3. Let's do another one. Now they want us to take X and subtract Z. Can we? Let's look at the dimensions. Here we have 2 rows and 3 columns, and here we have 2 rows and 3 columns. So we can, in this case, subtract them. So let's set it up. So there they are. We're going to subtract the corresponding entries. So we take the 4 minus the 2. There's a 2. Take the 7 minus the negative 2. 7 minus negative 2 would be 7 plus 2 or 9, and so on. The 2 minus the 3 for negative 1. The 5 minus the 1 for 4. The 1 minus 0 for 1. And the negative 1 minus 4 would give us negative 5. So there's a subtraction. Keep going. Now they want us to add X and Y. So let's see if we can do that. X is a 2 by 3, and Y is a 2 by 2. Can we add those together? I hope you said no, because they do not match. So this is something that we could not do. And the last thing we're going to look at is multiplying the matrices. We are not actually going to multiply them on the video. We are just going to look at the possibilities of when we can and can't multiply them. We have rules that apply when we multiply matrices. And here they are. Matrices A and B can be multiplied only if the number of columns in matrix A equals the number of rows in matrix B. And it will look something like this. If this was matrix A and this was matrix B, you see that the columns in A match the rows in B. And if you would proceed to multiply them out, your final matrix would have dimensions of M and P, which you notice was the rows of A and the columns of B. Well, let's take a look at how this works. Okay, so we have matrix A and B. And again, we have that stipulation. The columns in A have to equal the rows in B. So if we look at A, we see that we have 2 rows and 3 columns. So we have a 2 by 3, which is right here. And then if we look at B, we see that we have 3 rows and 4 columns. So this is B. B has 3 rows and 4 columns. You notice that, in fact, the number of columns equals the number of rows in B, which means we would be able to multiply them, and our final matrix would have dimensions of 2 rows and 4 columns. Now let's contrast that with this next one. Let's take matrix C and D. Our dimensions of C are 3 rows and 2 columns, so it's a 3 by 2. And D has 3 rows and 5 columns? Yeah. So if we write our dimensions down, C is a 3 by 2. And D is a 3 by 5, and you notice that we do not this time get the match of columns to rows. Therefore, another important vocabulary word for you is defined and not defined. See, we cannot multiply these together because the columns and rows don't match, so they are not defined. In this case, since we were able to multiply them, we would say that they are defined. So we're just going to look at a few examples of this. All right, we have A and B. We have A is a 3 by 4, and B is a 4 by 2. So we look at the column and the row to see if we have a match. We have 4 columns here and 4 rows here. So is this product defined? You would say yes, it is, because these match. And your final dimension would be the 3 by 2. Let's take a look at another one to see if it is defined. So our C is a 1 by 4, and our D is a 3 by 4. We look to see if we have a match of columns to rows, and we do not. Therefore, we would say this is not defined. We would not be able to find its product. Okay, let's take a look at this one. We want QP. You might want to pause the video and see if you can do this one on your own and then restart it. Q has dimensions of 5 by 3 and P has dimensions of 2 by 5. is this product defined? We have a 3 here and a 2 here, so no, not defined. Did you get it? And let's do one more. Pause it and see if you can get this one as well. We have S times R. S is a 4 by 5, and R is a 4 by 3. So is this one defined? We have 5 columns to 4 rows. They do not equal each other, so not defined. Not wanting to write for me. Not defined. Okay. So here's some examples of whether we have defined matrices so we could actually multiply them, or if they are not defined, then we cannot. Alright, so you need to bring all of your notes back to class from the 2 videos over our matrices, and we'll explore them further when we get to class.